Hi everyone, today we're going to talk about direct variation. You will need your textbook, so make sure those are handy. At the end of today's lesson, we are going to be able to identify direct variation, and if there is direct variation, we are going to be able to find the constant of proportionality. Direct variation is something that we actually already know what it is. We haven't called it direct variation yet, and the term itself sounds a little scary, but it's something that we have already been studying. So for example, if you have one book that costs $10 and I tell you that the books to the cost has a proportional relationship, then we know that 2 books are going to cost $20 and 3 books are going to cost $30. We've seen these numbers before in a table, so this is what we might have been looking at previously, a table of books to the cost. We know that the data in this table is proportional because we see that it's $10 for one book, we're finding the unit right here, $20 for 2 books, again, so that unit rate is $10 per book, and $30 for 3 books. When we reduce that, we get $10 per book. Because all of the unit rates are the same, we can say that this data is proportional. What this also means is that the number of books varies directly with the cost. So hopefully you can see the words direct variation embedded in that sentence. This means that the number of books varies directly with the cost. So direct variation, it's the same thing as proportionality, which is why I said when we started this that direct variation is something that we already know, we just haven't called it that yet. So right here, looking at this table again, we know that 1 times 10 is $10, 2 times 10 is $20, and 3 times 10 is $30. Hopefully you see the trend here. This 10 right here is what we call the constant of proportionality, or the unit rate without all those units in there. So that 10 is the constant of proportionality. That is how we are varying directly books to cost, by multiplying by 10. We've also looked at proportionality using a graph. So right here, let's look at this with direct variation. We have the same data that we just saw in the table, just in a graph version. So right here we have $10 is, oops, sorry, let me get my pen here. So we have $10 per one book. So this unit rate right here is $10 per book. $20 for 2 books, which is $10 per book, and $30. I'm just reading this over across right here. So $30 for 3 books. And again, this is $10 per, not pound. I don't know why I just wrote that. Let me erase that there. $10 per book. So with direct variation, you can see when all of these rates are the same here, when we're comparing our y value, this is the y-axis, this is the x-axis right here, we are getting 10 as our unit rate. The other important part of direct variation is that the data goes through the origin, 0, 0, and has a constant rate of change. Now, not every time you have a constant rate of change is there going to be direct variation. So I want you to make sure that these are two different things here. We have rate of change, constant rate of change, but we also have proportionality and direct variation. Just because you have a constant rate of change does not mean that the data is going to vary directly. So what I want you to do right now is I want you to open up your textbook to page 83, and I just want to talk through this example with you right here. When we look at this table right here, we're comparing numbers of pizza to the cost. The first thing I want to do is I want to point out to you that there can be a constant rate of change, but there can also, with that, not be direct variation. If we look at our rate of change right here, $11 to $19, this is a plus 8. From 1 to 2 pizzas is a plus 1. So right here, my rate of change is 8 to 1. This is going to carry through. 19 to 27 is plus 8. 2 to 3 is plus 1. 27 to 35 is plus 8. 3 to 4 is plus 1. So we do have a constant rate of change here, $8 per pizza. But let's talk about proportionality. I'm going to erase this, and now we're going to figure out the proportionality, which is written right here. So first we have $11 per pizza. The next group of data, we have $19 for 2 pizzas, or 9.5 or 9.50 per pizza. So you can already see right here that we do not have a proportional relationship. $27 for 3 pizzas is going to be $9. And then $35 for 4 pizzas is going to be $8.75. So this is not a proportional relationship. The rate of change was constant at $8 per pizza, but when the unit rates are not the same, it's not proportional. Now if you head right over here and look at this graph, this is a graphed version of this table right here. And as you can see, the rate of change, or the slope, is constant. We have a straight line, and the rise over the run is $8 per pizza every time. Now if you remember back a few slides, what I talked about, when you have a direct variation relationship, when you're looking at a table, it goes through the origin 0, 0. And if everybody can see, this graph right here starts at 4, which means that you do not have a direct variation here. This is starting at 4. This is not proportional. Our unit rates are changing every time. Just below this, we have example problem or practice problem C. I would like you to pause this video for a second, and I want everyone to try C. 2 pounds of cheese cost $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. So we're looking right up here. They give you a table to put that information. I also want you to graph it, and then I want you to tell me, is there direct variation and why or why not? So go ahead and pause the video, and then we'll talk about it. Okay, hopefully now you've had a chance to work through this problem on your own. Let's talk through it. The first piece of information they give us is that 2 pounds of cheese cost $8.40. So I'm going to find out my unit rate. $8.40 per 2 pounds of cheese is going to give me $4.20 per pound. Okay, so this is going to help me out when I fill out this table right here. They wanted to see how much 1, 2, 3, and 4 pounds of cheese cost. Well, we now know that 1 pound is going to cost $4.20. They gave us the cost of 2 pounds in the problem, $8.40. When I move up to 3 pounds, I can take 3 and multiply it for $4.20, or I can add $4.20 to this $8.40 right here. That will give me $12.60. And again, for 4 pounds, 4 times $4.20 gives me $16.80. So there's our table. Using that table just helped us answer the question to how much 1, 2, 3, and 4 pounds cost. Now for the table. Right now, I can fill out 0, 0. If I buy 0 pounds of cheese, let's hope the cost is going to be $0. 1 pound is going to be, we might have to, you gotta eyeball this a little bit here. 3, this is going up by 3s. So $4.20 is probably going to be right about there. 2 pounds, when I go up to $8.40, let's say that's there. My dots keep disappearing on me. 3, come on. 3 pounds is going to be $12.60. 4 pounds is going to be $16.80. So we say that's about there. As you can see, I don't have a straight edge right here, but typically we use a straight edge to connect our dots when we have this relationship here. Okay, so we have a straight line. It's supposed to be straight. Just pretend for right now. And it is going through the point 0, 0. So we know that yes, there is direct variation. There's a couple ways you could have explained this here. There's a constant unit ratio, unit rate here. There's also, when you look at the graph, it goes through the origin. So any one of those explanations would have worked. Now I want to talk about the equation for direct variation. We've talked about direct variation in a table form. We've talked about direct variation looking at a graph. And now I want to talk about it looking at an equation. The equation for direct variation is y equals kx. And I just want to dissect each part of this equation here. If you look at this graph that we've just been working with, the y-axis represents the cost. The x-axis represents the weight. So looking at this equation here, y is going to represent the cost in this example. X is going to represent the pounds. So now all we're left here is this k. What is k here? Well, we know that k is whatever we need to multiply the pounds by to get the cost, the pounds of cheese to get the total cost. We've already calculated that out to be $4.20. That is our unit rate. Our unit rate. So right here, I'm going to grab my pen. In this example right here, this k is going to equal $4.20. That's the unit rate. We are calling this k, and k is the constant of proportionality. So again, this nomenclature is new to you. This variable k, we're now calling the constant of proportionality, is something brand new to you. But the idea behind it, that unit rate, that's something that we have been working with. So with the equation y equals kx, y is going to be your first unit that you're comparing, x is going to be your second, and that k is your constant, proportionality, whatever you multiply x by to give you y, that is what k is. Whatever we multiply the pounds by to give us the cost in this scenario is going to be the unit rate. Okay, if we can turn to page 84, I just want to go over one more example with you. Direct variation with a table. So what we're looking at right here, determine whether the linear relationship is a direct variation? If so, state the constant of proportionality. Well, we know that direct variation is really talking about, is this information proportional? So to figure out if it's proportional, we need to find our unit ratios or our unit rates right here. So for our first, we have $12 per the time, whatever the time is, it doesn't tell us. Now, our next right here, we have $24 per 2 units of time, which is $12 per unit. Make sure we check them all. It's looking like it's going to be proportional at this point, but $36 per 3. That, when you reduce that, is $12 per unit of time. And last but not least, $48 per 4 units of time will give us $12 per unit of time. So, is this linear relationship a direct variation? Yes, it is. Our constant of proportionality, or we like to call now K, is $12 per 1 unit of time. Okay, we just went through a lot of new vocabulary, so I want to go through and review it with you. Direct variation. Direct variation is when the relationship between two quantities have a constant ratio. We also know this as proportionality. To figure out if something is proportional, we look and make sure that it has the same unit rates. Now, when you're looking at a table, you're going to compare the ratios or the unit rates for a common rate. If they all have the same rate, just like we do with proportionality, then we know that there is direct variation between the two quantities. When you're looking at a graph, you're going to look for a constant rate of change. This is going to be a constant rate of change. Where did my pen go? Is a straight line. And that straight line, very important, has to go through the origin. And last but not least, the other way you can look at direct variation is through an equation. The equation is y equals kx, where k is the constant of proportionality, or that constant number that you multiply x by to give you y. So what I would like you guys to do right now is I would like for you to pause the video. I want you on page 84 to try questions 1 through 3. When everyone's ready, I want you to start the video again and I will go through each of these with you. Okay, now that you've gotten a chance to go through these practice problems, let's talk about them. The number of cakes baked varies directly with the number of hours the caterers worked. So right now this is telling you that there's a direct variation relationship here. What is the ratio of cakes baked to the hours worked? And we get a graph. Now we have a straight line here that goes through the origin, so that reinforces that this is a direct variation relationship. What we need to do here is we need to pick one of the points. If this is the point that I'm going to pick, I need to read the y value here. So this is between 20 and 30. 20 and 40. This is going to be 30. And then coming down to read the x-axis or hours, it's going up by 1, so this is 1. Our ratio here is 30 to 1. 30 cakes per 1 hour. Number 2. An airplane travels 780 miles in 4 hours. Make a graph in a table to show the mileage for 2, 8, and 12 hours. Is there direct variation? So the first thing that I need to do here is I need to find my unit rate. I have 780 miles per 4 hours. When I divide this out, this is going to give me 195 miles per hour. I want to find 2, 8, and 12. So my hours that I want to put into this table are 2, 8, and 12. To figure out 2 hours, if I'm going 195 miles per 1 hour, I'm going to take 195. I'm going to multiply that by 2. That's going to give me 390 miles. To figure out 8 hours, how far that's going to go, I'm going to take my 195 and I'm going to multiply that by 8. That's going to give me 1,560 miles. And last but not least, 12 hours multiplied by 195 miles each hour, that's going to give me 2,340 miles. I pre-plotted this out so that you didn't have to painstakingly watch me do this, but here's our graph once we have this graph. And I do know that this was a little challenging because you had to interpolate in between the blocks here because we're going up by 3s for hours and 600 for miles. But if you look, you should have gotten pretty close to a straight line, and it does go through the origin. So there are a couple ways that we have already decided here that yes, this is direct variation. So you can explain that by saying there's a constant unit rate here, miles per hour. You can also say that once graphed, it's a straight line that goes through the origin 0, 0. This makes sense because if the airplane doesn't travel any miles, it's going to go any hours, it's not going to go any miles. Alright, number 3. Number 3 is asking how you can determine if a linear relationship is a direct variation. And it's kind of cutting this problem into 3 parts. First, if you have an equation. We know that there's direct variation in an equation if the equation follows the form y equals kx. So if the equation is in the form y equals kx, where k is the constant of proportionality, then yes, there will be direct variation. Now, if you are looking at a table, so looking at a table, you're going to have direct variation if there is a constant unit rate. And if you're looking at a graph, if you have the data going through the origin, which is 0.00, and it is a straight line. A straight line means that there's a constant rate of change. Then we have direct variation. So 3 different ways that direct variation can be disguised. You have to look at it a little bit